It's very nice. It's really very nice to see you all in person rather than in tiny images on the floor at which I'm not supposed to look. So it's really like giving a lecture. Now this is the end of the course, Lecture 5 that we've been talking about. Put the timer on so we finish in 2 hours and 15 minutes. Last time we ended with a seemingly insoluble problem. Induction in physics and philosophy, I've been saying, is essentially the same process. And I say, the essential feature of induction in physics is its use of mathematics. And I say, mathematics does not apply to philosophy. So how is this possible? Now this, for me, is the real problem of induction, if you will. And I think that its solution will finally illuminate for you the deepest roots and nature of induction, and perhaps some other important epistemological questions as well. Now, the material today is a bit more complex than what we've been doing. And I'm going to present only certain indispensable points. If you want a comprehensive treatise covering everything, I have to refer you to my book, which is indefinite future sometime. But I'm nevertheless going to try to proceed step by step. You may not always know where I'm going, but if you just follow my logical progression to the end, I promise you, you will finally get an answer to the dilemma that I just presented, but it comes late. Now, my first step, which will take some time, will seemingly make the dilemma much worse, because I am not going to try to show that somehow, despite the appearances, philosophy is really mathematical after all, just like physics. On the contrary, I'm going to devote something like a half an hour to arguing emphatically that the detractors of philosophy, the detractors, are completely right in insisting that philosophy is not mathematical. But, as we'll see, they don't know why it isn't, nor therefore how to interpret this fact in regard to the issue of judging whether philosophy is or is not an inductive science like physics. I'm going to start by a twofold thesis, one and then the next. And to give you an overview, it's going to be this. Not merely that philosophy does not use math, whereas physics does use it, but a much stronger thesis I'm going to uphold. That philosophy cannot use math, while physics must use it. And I want to put the point provocatively. This is my twofold starting thesis. A philosophy which uses numbers to reach or express its conclusions is a contradiction in terms. While a physics, now always leaving aside the very early stages of physics, a physics which does not use numbers is a contradiction in terms. That's as strong as I can put my thesis. Now these two ideas are inextricably connected, and the combination, I think, will lead us to the heart of the issue of induction in philosophy. And I'm going to start with philosophy and math, then turn to physics and math, and then cash in on it also. First, the inapplicability of math to philosophy. Now, please understand me here. I do not deny that states of consciousness exist along quantitative continua. That was stated in IOE, and I even stated that, a section on that in OPAR. There are certainly such things as bigger and smaller thoughts, more and less intense emotions, and so forth. All conscious processes, as Miss Rand points out, are conceptualizable by implicit measurement omission, which implies that they do have a quantitative aspect. But what I am saying today is that no matter how sophisticated we get in our measuring techniques, we will never be able to apply numerical measurement to consciousness. It is true that my love for my wife, say, is much greater than my love for birthday cake. But I will never, this is my thesis, I will never, even 40 millennia from now, and no matter what is discovered in the interim, be able to say that my love is 98.6 times greater. So I'm taking the view that consciousness is quantitative and thus measurable in the approximate implicit way described in IOE. But that it is not, if you'll allow me to use this word, it is not numerable, N-U-M-E-R-A-B-L-E. In other words, susceptible to the application of numbers, 1, 2, 8, etc. Now I want to tell you why. Why can't philosophy, as against physics, be mathematical? And the answer goes back to the essential difference between the subject matters of the two sciences. One studies matter, and the other the relation of a volitional consciousness to matter. Or more briefly, it's the difference between matter in one field and a volitional conceptual consciousness. And I'm going to give you 3 main facts about human consciousness, which point to 3 main arguments, all bearing on the question at hand and proving my point here. Now, all 3 of these are devoted to showing that philosophy cannot be mathematicized. And the first, I'm going to give you what I call the epistemological argument. I was just going to blurt it out and then explain it. In the pursuit of knowledge, human consciousness is inherently an integrating faculty. An integrating faculty. And therefore, there is no possibility of selecting from its contents a unit to serve as a standard of measurement. I'll say that again. Human consciousness is inherently an integrating faculty. And therefore, there's no possibility of selecting from its contents a unit to serve as a standard of measurement. An integrating faculty does not allow the selection of a unit. That's putting it even simpler. Now, I'm leaving aside here people who hold contradictions and the concrete-bound mentalities, because both of those errors can go only so far in any given human mind. And that introduces merely a pathology. But leaving that aside, the ideas or contents of consciousness are always parts of a single total state, a state which I would truly describe in the Greek phrase as a one in the many. And that state has no counterpart in the world of material objects. You can imagine material objects as merged and blended as you want. But in principle, the constituents of a table where you put parts together, or a cocktail where you blend liquids together, or a metal alloy, or even of an atom, the constituents of all those things can be separated out again in principle and can exist without connection to their former whole. The parts retain some independent, self-contained identity of their own, and therefore they have the ability to exist apart from the former whole to which they belong. But the constituents or contents of a mind are not like that. Now, I'll give you the ideas of objectivism, for example. Once those have been integrated by a mind, blended, put together, they can no longer be separated out as independent, self-contained forms of consciousness. You can't take them apart once you put them together. You can, of course, focus on one idea that you hold as against another, but you can no longer separate them after you know their logical connection. Not the way they were really separated in your mind before you learned the connection. And I'll give you a perfect example. When I was a teenager, I easily could and did think of capitalism on the one hand, and of the axiom that existence exists on the other, as two different, unrelated topics. And I couldn't understand why Ayn Rand seemed to treat them somehow as related, and even as one issue, It was blurring, it was confusing. How did she put these two together? But today, after writing chapter 11 of Opar, either of those two ideas inextricably involves the other in my mind, and I can no longer, as I once could, view or treat them as independent, self-contained mental ingredients. They've been integrated, they're one now. It's in the exact same way that you all know the concept table to you involves all known and future tables which you can no longer view or keep in your mind as simply separate independent concretes. You see them as table, immediately it's part of the total. Whereas as babies, you could look at this one and that one and that one. They're three separate independent contents. That's what I mean by consciousness as an integrator, not just a blender. If it's an integrator, then it must continually elude any form of numbering or counting, because there is nothing truly separate or separable to constitute a unit. Nothing to break off or mark out from the total by reference to which to measure the rest. There is only, in fact or as driving tendency, the one all-encompassing cognitive total. Now think about it. What, even in theory, could constitute a unit of thought? What is one idea? Now we have no trouble with 1 foot in regard to length, or 1 pound in regard to weight. But what is one thought? Now here are some examples, and I can do this indefinitely. And it's fun at first, and then it becomes ridiculous. Imagine Ayn Rand thinks of the idea of the moral-practical dichotomy. And then she thinks of a second idea, the love-sex dichotomy. And then she puts these two together. She says, aha, the mind-body dichotomy. Now what is the arithmetic here? 1 and 1 equals 1. Now you might say, oh, well, that's not fair because there's 10 forms of the mind-body dichotomy. So she only had 2 of them. So then the arithmetic would be 1/10 and 1/10 equals 1. Now those are ridiculous. And there's many more on that order because numbers don't apply. What is the unit? What constitutes one idea? Now colloquially, we apply numbers to consciousness all the time, and it seems to be unproblematic. For instance, you say one man has no ideas on philosophy, and another has only one idea. He's a monomaniac in this subject, as Spinoza was said to be in regard to God. And still another is so fertile he has dozens or tons of ideas. But now I want to ask you whether any of this has literal, numerical meaning. Does it have any literal meaning other than the first man never thought about X, the second man is obsessed, and the third man has an active mind? Or, since numbers don't apply, does it necessarily even mean any of these? Maybe the man with no ideas has many implicit ideas on philosophy. And in fact, we know he does because no one can escape philosophy. But how many implicit ideas does he have? Who could count them and how? And what about the fact that the one-idea man, the God-obsessed Spinoza, wrote out an entire philosophy in 5 books, including hundreds of numbered propositions? And at the other extreme, the man who's so fertile with tons of philosophic ideas may very well, especially today, be teeming with nothing but trivial variations of linguistic analysis. So does he have a huge fund of ideas, or only one idea, linguistic analysis, or given the fact that his philosophy is the negation of the faculty of abstraction, he has no ideas at all? Now, in regard to length or weight or any physical attribute, What we do to apply numbers is we pick any arbitrary perceivable bit of it, any arbitrarily chosen perceivable bit of it, which we then can easily separate out in thought to serve as a unit. But how can you pick an arbitrary bit of identifications and count that as one? You can't. Now the same principle applies to any aspect of consciousness. I'll give you one more example. I'm still on the first argument for the first thesis. I'll give you one more example from the emotions. You cannot pick out a unit, say, of fear, because an emotion is always part of a total affective context, a total state of consciousness, which permeates every aspect of the emotion, including its very feel. Is your fear tinged by guilt, since a hero should not be afraid, you think? Or is your fear overlaid with desperation or futility, being tied into your general depression, say, or your malevolent universe? If so, maybe your fear will prompt you finally to end it all. So maybe the fear comes with a dollop of relief. Or is your fear strong but barely noticeable to you, even though it's really strong because you're so well trained in repression, etc.? It is the same thing as with ideas. There is no separable nugget or bit of fear to pull out as a unit. The emotion is inseparable from the total state of your affective consciousness, because consciousness is a total, it's an integrator. I want to take an aside from my first argument to my first thesis. But it's helpful. It was helpful to me anyway. This point about consciousness being an integrator and therefore not numerable explains why it's impossible to apply numbers in the definition of various epistemological terms. For instance, take the term essential. Now, the essential, by definition, is that which underlies all or most of an entity's distinctive characteristics. But how many attributes of an entity are the most? You just can't come up with a number. For instance, I take the two definitions. Man as a rational animal versus man as a thumb haver. Well, obviously, one explains the most, but can I say, well, Aristotle explains 304 times as many attributes as the thumb haver. That's obvious you can't do it, because numbers don't apply to consciousness. And here we're talking about our organization of knowledge into categories. And similarly, when we validated the atomic theory by showing that it's a superintegration of fundamentals, which thereby explains more than any other possible theory in the field, such as the fluid theory. But can you say the more is 5 or 500 times greater than what the fluid theory explains? No way. The reason is the same. The science of physics is a content of consciousness. And consciousness, including its content and the epistemological concepts which govern it, is not mathematicizable. Now that's my first argument, just to get the thing rolling. The epistemological reason why consciousness is not numerable. Now for the ethical argument. One consequence of the fact that a conceptual consciousness is an integrating mechanism is that man can pursue values only by the guidance of chosen principles. Principles in some form, and I assume you know this from previous books and lectures and so on, principles in some form are our only means of choosing a course of action, and thereby our only means to the achievement of values. So principles are inescapable to men, even if it happens against their will, even if they're deliberate, quote, moderates or active pragmatists. They can't get away from principles, in some terms. But here the crucial point is principles are not a matter of degree. In choosing any principle, whether you do it consciously or otherwise, there is only one alternative: yes or no. I choose to live by it or I don't. A or non-A, either or. Or to use computer language, 1 or 0. In other words, here we have another crucial difference between physics and philosophy, over and above the unique nature of consciousness as an integrator. And that is that the objects of physics exist in degrees and are studied by a reference to their degree in any particular case or experiment. But in philosophy, there are no degrees. Yes, no degrees in philosophy. I know. I really never thought of that. No. There are PhD degrees. No more or less, and I'm going to make that good in a minute. Maybe I should say no deserved degrees by people who have tenure. Now the underlying point here is that matter moves by what Aristotle called efficient causation, in which an antecedent factor necessitates a result through some kind of physical contact. The simplest model being one billiard ball hitting another and rebounding. And clearly you can measure the degree of the attributes of the interacting entities, the degree of the mass of each, of the velocity, and the degree of the nature of their contact. For instance, the degree of the force they exert on each other. All the qualities of these entities and their contact exist in varying degrees and are therefore numerable. Billiard balls are not an issue of mass or no mass, take your choice. But you cannot say anything like this in philosophy. Now I want to take a political example here, a deliberately startling example, which is still true. Physically, you can be hot, and then even hotter. That's a physical quality that always exists in some specific degree, and which changes when it does through efficient causation. But you cannot be free and then even freer, because this is an issue of principle that comes under what Aristotle called final causation. In other words, the pursuit of values. Now, of course, we say colloquially all the time that there are degrees of freedom, that the U.S. is freer than Singapore. But you can't say it literally, not as you do in physics. And the reason is obvious. Freedom is a matter of principle. Either you live in a country that recognizes individual rights, you're free. Or you do not, in which case your freedom is gone. Gone in principle. You are then functioning by permission, and it's only a matter of time before the permission is withdrawn. Now, this is the same issue that I discussed under integrity in OPAR, when I said that virtues do not come in degrees. It is impossible to be an honest man and then even more honest. As soon as you start telling lies, you're not honest. Now, there can be bigger and smaller liars, but the choice any man faces is the principle of telling the truth or its rejection. And an important corollary here is that there can be no numerical laws of philosophy. Even the most well-established of philosophic laws cannot be expressed numerically. For example, take Ayn Rand's statement that reason and freedom are corollaries. This is a law of philosophy, if anything is. But it can't be translated into there is a numerical concomitant variation between reason and freedom. If reason goes down 7 units, freedom will go down 7. Or if it's the inverse square, will go down 49. Now, why can't you do that? Because the philosophic law stated fully is, if reason goes down, then it has been rejected in principle. And therefore, so has freedom been rejected. So in the long run, dictatorship will ensue, unless somebody fights the trend, such as Ayn Rand writing Atlas Shrugged and starting to change people's minds. And understanding, of course, this is part of the law, that the long run can include people oscillating back and forth for many decades in regard to freedom because of conflicting values. You see that this is a law, but it is utterly different from measuring the pressure and volume of a gas and then observing that if the temperature is constant, they vary concomitantly. There's no comparison. In philosophy, the whole enterprise of formulating laws that relate variables existing on a continuum is out. Now, don't get me wrong. There are laws of philosophy. My point is that they are not numerically expressible or measurable. They are laws stating the consequences of volitionally accepted values and principles. And as such, what they state is this: allowing for all the combinations of possible choices, errors, contradictions, and reversals among men, then a certain consequence is ultimately unavoidable. There are no numbers that can capture this kind of truth. And that brings me to the third. I'm turning because the lectern is working to sever me just below the kneecap. This brings me to the third and last argument that I know of as to why consciousness and philosophy are not numerable. What we can call the metaphysical argument. And I really mean by this the primacy of existence. The issue that consciousness is nothing but the faculty of perceiving existence. All the actions of consciousness, this is a bromide of objectivism, directly or indirectly are forms of being aware of, relating to, responding to the material world. Consciousness has no nature to explore or know in itself, intrinsically, so to speak. Its nature is to look out, only in essence to perceive matter. Now, matter is something on its own, apart from consciousness, whereas consciousness is nothing but the awareness of it. Now, this, those of you who know the modern philosophy will realize that the major error here was committed by Descartes, who was a dualist, and he postulated that the universe consists of two self-contained independent substances: the thinking thing and the spread out or extended thing. And they could go their own separate ways. Now that is exactly what I am disputing here. Now, of course, I don't deny that consciousness has identity. I wrote a whole thing on that. But what I am saying is that everything pertaining to and causing its identity relates to its physical instrumentalities. For instance, it has a certain type of sense organs and a certain type of brain, and that creates a certain type of consciousness with a certain type of way of functioning. But I'm speaking now of the actual phenomenon of consciousness itself, apart from its causes, the simple state of being conscious. That is unanalyzable, because it's nothing more than the looking outward at an object. By itself, apart from any object, that state is by definition contentless and characterless. It's non-existent. So there's no mystery about why it can't be quantified numerically. Counting is a process applicable only to entities and their attributes. But conscious states are not entities. They are merely the awareness of entities. Now, I'm sure someone wants to ask here, because it's the thought that occurred to me next, how can processes or states of consciousness be measured, even implicitly and roughly, as we said that they were when we conceptualized them, if consciousness is, as I say, in effect, in itself, nothing? And my answer is that consciousness is measurable, non-numerically, but is measurable only because of its relation to matter. And one way or another, it is always the matter that is being measured when you measure consciousness, not the state of awareness as such. For example, we talk of a broad thought. That's a measurement of consciousness. But what constitutes its broadness? It's one that covers or subsumes more physical objects or attributes than a narrow thought. So the approximate measurement is how much matter does it subsume? Or take an intense love versus a feeble one. Well, an intense love is one expressed in action, in certain specific choices of action. Now remember here that emotions are responses to value judgments, and a value is that which one acts to gain and or keep. So the measurement of an emotion is really the measurement of certain actions. That's what Ayn Rand describes as, do you remember? Teleological measurement. And she elaborates that. I refer you to her chapter on that. But I want to sum up this point this way. A disembodied consciousness, one detached from matter and action, would have no thoughts or feelings at all, let alone any degrees or measurable qualities. So I come back to my point. In regard to consciousness, alone by itself, there is nothing there to be measured. Now, one more example of the point that only the physical is numerable. Consider physical actions which follow from conscious decisions. Such actions can be numerically measured, but one then measures only what? The physical movements of the body, not the movement regarded as a product of consciousness. Every movement of a juror's body in uttering a just verdict, for example, is numerable. Every flutter of his tongue. But his justice is not numerable. Once consciousness enters the picture as an essential part of the action, numerical measurement is out the window. And of course, actions are of interest to philosophy, as against physics, only insofar as they are a product of consciousness. I actually wrote, pause and sigh. So to sum up so far, conscious processes are quantifiable, but numbers, and therefore counting in mathematics are not applicable to consciousness. And since consciousness is the essential subject of philosophy, this means that number and math are not applicable to philosophy, not to any question, not to any branch within philosophy. Draw a big line. Obviously, number does apply somewhere, and it's crucial in that venue. And that brings me to the second of my theses, the indispensability of math to physics. Now, throughout this whole discussion, I'm leaving aside the early stages of this subject, and I'll explain why in a little while. Leaving that aside, let's ask, why is math so indispensable? Why is physics without numbers, without mathematics, impossible? Why is it that math does something crucial for a physicist that nothing else could ever do? That's a big question. And I don't think anybody has answered that question properly. Now, for instance, if you ask people this question, the standard answer I get, the bromide, well, math is crucial to physics because math is exact, whereas qualitative statements are not. And they say qualitative statements with acid dripping from their tongue. Now, this is ridiculous. Isn't the law of causality exact? Isn't it an exact statement to say that man needs capitalism in order to survive? So I say, don't be taken in by people who tell you in any variant that quantitative statements are more reliable than qualitative ones. That very statement is qualitative. Now, most of the alleged compliments given to math by its admirers are just like this one. They're nothing but smears against non-mathematical subjects. Smears that arbitrarily equate math with reason, with precision, with science as such. So I want to look now for a true and not a Reader's Digest type answer to the question. I use Reader's Digest because I don't know if it still exists, but in the old days, it always had superficial articles. 13 reasons why a scientist believes in God while pruning his rose bushes. All right, now I want to translate the question we're dealing with into broader terms first. We're asking, why is math so crucial to physics? Physics is the archetype of a science devoted to knowing external reality. So our question really is, what does math do for man? Why is it so indispensable in knowing external reality? Now, we're not speaking here of knowing reality on the perceptual level, because percepts are automatically given, they're infallible, we don't need any math to grasp them. So let me reformulate the question again. What does math do for man in knowing external reality beyond the perceptual level? Since that's where it does something. Now, do you remember my opening definition of induction? It's the process of gaining knowledge that go beyond the perceptual level. So we're really asking the question, if you could take one translation after the other, what does math do for man when he induces? Or if you like it, what does math do to solve the so-called problem of induction? Now I'm going to answer all these questions in a single paragraph because I do not know. Maybe in 10 years I would have the skill. I don't know how to lead you to it one point at a time so it's obvious. All I can do is just blurt it out, hit you over the head with it like a sledgehammer, and then try to chew it so that it becomes intelligible. And this is my central thesis today. Granting that consciousness itself can't be numerically quantified. Nevertheless, human consciousness on the conceptual level is inherently a quantitative mechanism, an apparatus for processing quantity. Let me repeat that, because that's my whole point. Human consciousness on the conceptual level is inherently a quantitative mechanism. It is an apparatus for processing quantity. Our minds grasp reality, and by that I mean they grasp the attributes of entities and they grasp the causal relationships of one thing to another. Our minds grasp those things only through grasping quantitative data. So let me repeat, we grasp the qualities of things and their causal relationships only through grasping quantities. And in this sense, I maintain quantity has epistemological primacy over quality in studying the external world. Now, I'm speaking here epistemologically, not metaphysically. Pythagoras is wrong in holding that quantity is the substance of reality. It's not true that all things are numbers. Quantity, after all, is always quantity of something, of some entity, of some attribute, of some quality. But quantity, I am saying, is the key to epistemology, to the nature of human knowledge. We can identify quality. We can identify the qualities of things only through grasping quantity. And we can identify causal relations between entities and their actions only through grasping quantitative relations. That's my thesis. Now, why do I say this? Well, I believe the answer is actually implicit in Ayn Rand's theory of concept formation. In my own mind, I'm only giving a different statement of her revolutionary discovery. So let's first ask, how do we know what a given entity is? How can we identify that this thing is a, quote, table, or that this quality, going along the edge, is an instance of length? I'm choosing deliberately examples that she used. How can we identify table, length? Well, her answer, of course, is we identify in terms of concepts, which, she says, are integrations of their reference. Integration is possible to us. Why? Because we first establish quantitative relations among those references. In forming a concept, our minds have to grasp that its various instances are commensurable. This I discussed in OPAR. In other words, reducible to the same perceivable unit. And therefore, we're able to grasp that the instances are the same except for their varying measurements. They're different relations to this same one unit. And the simplest example that Ms. Rand gives is we take any perceivable instance of length and relate all other instances back to it, and we can relate them back because they're either more or less, or the same. And we then omit these varying measurements. The result is a conceptual category to which all the instances belong, length. And the point is that they belong because of the measurable characteristics. They belong because they were all commensurable reference. They are all existence we can measure using the same unit. Now, length is a simple example. Ayn Rand works out many others. And the same principle applies sometimes in very complex ways to forming concepts of entities and to all other types of concepts. So what do we actually, though, mean when we say, I know what something is? I know what that thing is. What you actually mean in terms of the mechanics of your mind is, I know what it is through a quantitative processing of data which my mind performs. I know what it is through grasping the quantitative connection of its instances to some perceivable instance taken as the unit. I know what it is through a quantitative processing of data. Now, Ayn Rand points out what the crucial result of this quantitative relating is. And that is to bring the whole universe down to our scale of perception and thus make everything in principle knowable. And that already gives us the first key to understanding induction. If we ask the question, how are we able to gather knowledge beyond the perceptual level? The answer is by discovering quantitative relations to a unit, by being able to produce all lengths, no matter how huge or tiny, no matter how inaccessible to our scale of perception. We reduce them all to this length, this one easily graspable in front of my eyes. Now, in concept formation, Ayn Rand points out, we in essence create what she called file folders. And since we place all the instances of a concept, known and unknown, into the same folder, we're ready now to induce. We have the green light now to go out and obtain data, information, facts, by studying some of these instances, and then we can generalize, extrapolating our conclusions from some to all of the other instances in the same folder. Now, our generalizations, as we've already seen, involve the discovery of causal connections through difference and agreement. So the key to gaining knowledge of external entities, the key to this generalizing process, in other words, the key to actually filling the folders with cognitive content once we form them, lies in grasping the causal connections which makes possible inductive generalizations. So now let's try to x-ray that process. How do we, in the deepest sense, grasp causal connections? What is the basic method our minds use? The method that underlies and makes possible the methods of difference and agreement. And here is the striking thing. It was striking to me when I first thought of it. In essence, the method is the same answer as in concept formation. Just as in forming concepts, so in grasping causes. We know through quantity. In concept formation, we interrelate instances quantitatively within one single category. For example, we relate all men to one another under the word man. And to do so, of course, we have to implicitly measure and then drop the measurements. But now in seeking cause and effect relationships, we're trying to relate objects or attributes of different kinds, coming under different concepts. In looking for cause and effect, we're trying to find the effects of one kind of object, let's just call it object, on another kind. We're trying, for example, to see how temperature affects pressure, or whether the length of a pendulum is a cause affecting its period, or whether the distance between two objects affects the gravitational force between them, etc. And here, too, if you think about it, you will see that the key to grasping causal relations among different objects is quantitative. In fact, as we saw in past classes, that's exactly what experimenters do to discover causal relations. They measure and establish relations between quantities. Now I want to go deeper. Why is this what they have to do to grasp causal connections? Forming a concept is only the preparation for knowledge. It's only the formation of the file folders. But when we reach the stage of science, we're looking out at the world and trying to fill those folders. And in such a case, the scientists have only two tools at their disposal, both made possible by our conceptual faculty. First, since they've learned a whole vocabulary, they're able to pursue specialized knowledge. For example, to seek out the relation specifically between temperature and pressure, which requires them to disregard all the irrelevant things that flood their perceptual field along with temperature and pressure, such as color and shape and folk dances and so on. Our abstract vocabulary, in other words, enables us to single out factors and ask specific causal questions. How does A affect B, ignoring everything else? And the other tool in the arsenal, and the most important to us now, our conceptual faculty makes possible another crucial element in our ability to fill the file folders. It enables us to form concepts denoting pure quantities. In other words, quantities abstracted from any particular physical setting. And that's what we call concepts of numbers, which gives us the ability to measure not just subconsciously, relatively, approximately, as we do in concept formation, but now consciously, absolutely, and numerically. Now, this is the thing to see. Once he has these two assets, the scientist does nothing actually new than the person who formed concepts to begin with. It was not a scientist. The scientist merely continues with the regular human method of transcending the perceptual level and gaining knowledge. He continues the process of quantitative relating, of establishing quantitative relations. But this time, seeking causal connections, he relates objects from different file folders to one another by means of an explicit conceptual method of grasping quantity. Numerical measurement. That is the conceptual method of grasping quantity. Numerical measurement. Pre-conceptual measurement. That is the implicit, relative, approximate kind that we use to form concepts, is one thing. But concepts once formed, in turn, make possible conceptual measurement, which is the climax and only fully developed form of measurement there is. And that's what we mean by numerical measurement. And this is precisely what physicists use and have to use. All that the physicist does, all that as a formed human mind he can do at this point, is to identify numerical relationships among objects and then generalize to numerical formulas. While we, looking on, say quite correctly, oh, look, he just discovered cause and effect. And here, too, as with the original formation of a concept, the numerical formula, for instance, F is proportional to 1 over R squared. The numerical formula brings down to the scale of our perceptual level an unlimited number of instances beyond our perception. And I mean here not just the unlimited number of instances which every general formula covers, but also the scale of magnitude going up and down which the formula makes accessible to us. To simplify enormously, and I know, Dave, this is all wrong as physics, but it's just as a crude example. We study the fall of an apple, an easily perceivable case of a force at work. And we can shortly, ultimately deal with the force of attraction that one galaxy exerts on another. Or we learn the laws of behavior of charged balls, easily perceivable objects. And we can shortly deal with the electrical force exerted by subatomic particles on each other. Now, what I want you to see from all this is that I'm comparing two things which sound like apples and oranges: concept formation and the practice of physics. But in my opinion, the exact same principle is at work in both. They are merely two expressions or variants of the same quantity-oriented faculty of cognition at work. In concept formation, we start with the perceptual level, the level of concretes. You remember Ayn Rand in her analogy compared that to arithmetic. And then she said, we abstract and ascend to algebra. Well, this is exactly what the physicist does. Exactly, but he does it in numerical terms. In physics, the equivalent of the perceptual level is the numerical measurements taken by the experimenter, who is first of all a gatherer of specific numbers. That's the arithmetic of physics. And then the equation or law reached by the end of the experiment, just like in concept formation, is a process of abstraction to rise to the algebraic level, which, once formulated, enables the physicist to know not just a handful of perceived instances, but all the rest of the instances scattered throughout the universe, no matter what their number, time, period, or scale. So, human cognition, in essence, I'm simplifying, I know, it'll take a book to put all the qualifications in, but I'm trying to get out the central idea here. Human cognition, in essence, is two forms of measurement: approximate and preconceptual. You just say bigger than, smaller than. Numerical and conceptual. Both necessitated and performed by the same kind of consciousness. One which basically knows only through identifying quantities. Is that enough to think about to justify a 5-minute break? Okay. Let me pick up by repeating that last paragraph. Human cognition, in essence, is two forms of measurement: the approximate preconceptual kind and the numerical conceptual kind. And both of these are necessitated and performed by the same kind of consciousness, one which at its root knows only through identifying quantities. If we could know qualities, now remember we're talking about the external world. If we could know qualities directly, without any quantitative processing, if we could know everything about a quality by simple perception, then we could know causal relationships directly without numerical measurements, simply by perception. Now, on the lowest levels of cognition, in the early stages of knowledge, we can approximate this purely qualitative approach, because we can hold early-level concepts and early-level gens ostensively and perceptually. So, for example, simply to know in some terms what fire is and that fire burns, all we have to do is point to it and stick our finger in it. We don't have to measure anything, you just simply yell ouch. But on the higher levels of cognition, this does not work. On these levels, a conceptual consciousness can identify qualities and their relationships to one another only through measurement. And this is my answer to the question of why numbers have to be applied to the external world, why physics must be mathematical physics. And the answer, to repeat again, I know I'm repeating, but it's a new idea, and you won't believe that I believe it. So the answer is that mathematical physics is necessitated by the fact that a conceptual consciousness can know objects only through measuring, only through relating quantities. Now, I hope you're not going to ask me to go deeper. I hope you're not going to say, why does our consciousness work only through quantity? Because my answer is, it is. This is the fundamental beneath which so far I have no clue how you would get. Now, I will add for your information, but I'm not going to discuss or elaborate, that Miss Rand herself was particularly interested in studying neurology. She believed that a study of the brain would be extremely illuminating for the study of epistemology. Conceivably, this is my wild guess from what she said, and don't ascribe it to her. Conceivably, neurology might throw a light on why our consciousness operates only through quantity. But this is the wildest speculation, and about neurology, I know less than a kindergarten student knows about calculus. Now, I want to try to come at this thesis about quantity from another point of view, because you may find it helpful. You could think of the relationship between concept formation and physics as follows. Physics completes the job of concept formation. Physics completes the job of concept formation. In concept formation, we prepare objects for knowledge by measurement omission. We know, of course, that measurements exist, but we deliberately don't specify them. At which point, assuming a whole vocabulary, including the concepts of number, the physicist comes in and says, now let's start specifying them. In effect, the physicist says, I'm condensing here, but let's put back in some of the measurements we deliberately left out at the start in order to form our concept. Now, using our system of file folders, let's put those measurements back in numerical terms and see what quantitative relationships we can find. I'm trying to put this ever more simply. We omit measurements to form concepts. The physicist then specifies these same omitted measurements, or some of them at least, but he does so in numerical terms. And thereby he grasps the relations between one set of numerical measurements and another. In other words, between one type of attribute and another, and we call those relations the laws of nature. Now, I actually worked out an example. I got here a simple example, but it's not a simple example. There are no simple examples that I can think of. I'm taking this from Galileo. The experiment in which he showed that the length of a pendulum is proportional to the square of its period. See how easy that seems now by comparison? Now, you could express this equation in terms of the two variables, L for length and T squared for the period. And if you want to make it an equal rather than a proportion, just say L equals some constant times T squared. And we can ignore the constant. Now, we're assuming here, just to cover this point, that the experiment takes place at sea level, so don't bother with that. Now I want to look at the whole cognitive development here, from start to finish, from pre-science on through Galileo, in essential X-ray terms, many simplifications. You can't get the length of a pendulum before you have length. So first we form the concept length by measurement, by implicit relative measurements. That's the issue of the instances have to be commensurable, which we then omit. We don't care whether one is longer or shorter than another, as long as it can be related to a unit. Then we use that concept once formed. In this case, we're using it to identify a narrower category, the length of a pendulum, which we're calling L. So that is still a conceptual unit, because it subsumes an endless number of concrete lengths of different pendulums. Now, similarly, we form the concept of time. At the very beginning, before we know anything about clocks and so on, by implicit measurement omission from perceptual experiences, such as a short time or a long time, more than this stretch of time I'm sitting through or less. Or you could do it more sundial shadow movement or less, whatever you want to take as your most primitive way of getting time. Then we reach science, we subdivide time, and one of the subdivisions is period, the amount of time it takes to go back and forth. That's still a concept which subsumes an endless number of concretely varying periods. And we formed it by saying we don't care how long a period is. It's the unit, it's the amount of time. So we've been dropping measurements like crazy to form length and time. Meanwhile, of course, we have a whole conceptual apparatus along with the concept of numbers. What does the physicist then come in and do? He says, let's measure length. Let's measure time. Let's do it numerically. Let's get their relationship in concrete cases. So he measures the relationship in this pendulum, in that one, in that other one, in the very ones that we said, let's ignore how long. Let's ignore the time measurements. He comes in and says, no, that's the essence of it. Let us find those measurements. And then he generalizes and finds, that L is proportional to t squared. So that if he knows the measurements of either variable in a specific case, he knows the measurements of the other. And therefore, the algebraic formula that he reaches, the L is proportional to t squared, states a law of nature. So you see that what Galileo puts back in when taking measurements are in essence what he and we dropped out in forming the concept, although we dropped it out in non-numerical form. When Galileo formed length, he focused on specific lengths in relation to some bit of length. And he noticed that this length was bigger and that one was even bigger. He had no numbers at that point to identify the differences among them, but he perceived the generalized quantitative relationship. He grasped the commensurability of all these instances, and thus formed the concept in file folder. Then, as an adult, he focuses in essence on the same concrete length, but thanks to the conceptual apparatus he's developed, including the concepts of numbers, he can now tell us that the one which at first he could only implicitly say was bigger than is 6 times bigger than 1 foot taken as the unit. Whereas the one that he could only think of as much bigger than is, let us say now, 15.8 times bigger. I'm trying still another formulation. One of these formulations will make it clear to you, I hope. So this part of the lecture, I just tried one way and then another way and then another way, thinking at some point, the story about Bertrand Russell, at one point he was walking through the field and he suddenly understood why the ontological argument for God is true. And it left him thereafter, but he remembered he had that one moment of illumination. So I'm trying to give you one moment of illumination here somewhere. This is my next formulation of the idea. There is nothing a scientist studying a conceptualized physical world can do after the initial qualitative pre-scientific stage. Nothing he can do to grasp the relationships among objects except to reinstate in numerical terms the very measurements that had to be dropped for him to conceptualize the world in the first place. You get that? Should I repeat that? There is nothing the physicist can do if he wants to grasp the relationship among objects except to reinstate in numerical terms the very measurements that had to be dropped for him to conceptualize the world in the first place. And the laws he thus reaches then tell us in abstract form the necessary connections between his measurements. And then it's all the story we told. Rising progressively by this same method to the level of Newton and Maxwell, he identifies the fundamental causal relations operative in the universe and thus explains all our earlier observations, including our measurements. And what I'm trying to say is that this whole thing must be so by the nature of our conceptual faculty. That's the second half of my first part, the double thesis. On the one hand, the very nature of a conceptual consciousness mandates numbers in the study of material objects, even as it forbids numbers in the grasp of itself and its own states. Another big line. A new topic. Everything I said so far presupposes a certain view of numbers, of mathematics. It depends on knowing what numbers in math are. And above all, it depends on knowing what is the relationship between math and reality. Obviously, you can't properly understand the role of math in physics if you don't know first the role of math, the relation of math to reality. The relation of math to reality, put that as your title of this subsection. Now, in this issue, as in so many others, the dominant theories, tragically, are the two false theories that have ruled philosophy for eons, and especially since the Renaissance. Both of these theories make the role of math in physics inexplicable, and both end up wrecking the very subject of physics. And of course, you can guess the two approaches I mean. Which two? Intrinsicism, well, you can call it rationalism empiricism, but I'm thinking of it in terms of intrinsicism and subjectivism as against the objectivist approach. And I want to look at each briefly in terms of how it relates math to reality. Now, the perfect example of the intrinsicist is Pythagoras or Plato, and they make numbers metaphysical. If you ask them, why does physics need math? Well, they answer, in effect, God thinks in terms of numbers. His thoughts are equations, and he formed reality accordingly. And if you ask them, which is a common question in the philosophy of math, why are the numbers in physics so simple? You know, they really are simple. There's something there. For instance, you have an inverse square law. You don't have the force inversely proportional to the distance to the 1.538 powers. It's just the distance squared. A really easy number. Now, I know they're not all that easy, but there's a lot of them. And the question is, why are so many numbers in physics so simple? Well, the intrinsicist answer is, that's obvious. God thinks in integers. Or some of them who are more inclined to geometry say he thinks in terms of regular solids. Now, why does God think this way? And the Christians answer, that's God's will. He can do whatever he wants, so why shouldn't he do that? So on this view, there is no necessary connection between numbers and cognition. It's only, that's the way God chooses to think so far, let us pray. That's the Platonic or rationalistic approach to the relation between math and reality. And it does, unfortunately, have a very strong manifestation in current physics. And I mean the pronounced tendency in Einstein, who ends up reducing physics ultimately, if you read him, back to free-floating Platonic equations, which Einstein explicitly says these equations form part of the mind of God. Is that true? Now, the intrinsicist approach explains nothing about the need of math in physics, because supernatural explanations never explain anything. And it ends up wrecking physics. It detaches physics from matter, turning it into a string of floating, supposedly cosmic equations, and thus preparing it nicely to blend into the floating, cosmic-sounding abstractions of Oriental philosophy, a process of blending which is rampant around us today. Now let's look at subjectivism on this topic. In this view, obviously, numbers are purely subjective. They're creations of consciousness, pure and simple, and we can create and manipulate them in any way we want. It's all a matter of our arbitrary choice. In regard to numbers and math, these people say reality is simply silent. So if you ask these people, well, why does physics need math then? They have only one answer. It turns out to be convenient. You said, but why? They say, it just is. Math happens to work. Our arbitrary equations, even though they're unrelated to that myth that you call reality, turn out to be very useful in predicting the flow of appearances. Now, here again, there's no explanation of the role of math in physics, and here again, physics collapses. Because instead of turning to a supernatural reality, as in intrinsicism, the physicist of subjectivism simply drops reality as a needless complication. We're supposed to not multiply entities beyond necessity. And reality is one of the ones we got to get rid of. So they say, don't be metaphysical. And then he goes out to so-called save the appearances through any subjective postulates he feels like, no matter how fantastic. Now, in modern physics, the best representative of this approach is quantum mechanics, despite whatever virtues I grudgingly grant it to have. And if you want an example, I refer you to Schrödinger's cat. If you know the one I mean, that he is and isn't alive inside the box. I think he's also neither alive nor not alive, and he has various other... That's what they feel like. Now, of course, the truth is that numbers in mathematics are objective. They are not intrinsic in reality, nor are they arbitrary creations of consciousness. They're facts of reality as processed by our cognitive faculty. So reality is there, and consciousness contributes. Now, what about first the facts of reality? The metaphysical facts that underlie math, the facts contributed by reality, which are not a function of our cognitive faculty. I'd say there's two things given by reality that would be there with or without our presence. Number one, entities are real. An entity is the base of the concept one. So one is based on the fact of reality, independent of our consciousness. And two, variations in quantity are real. They're real independent of us. In other words, the spectra of bigger or smaller, taller or shorter, etc. Now, I say that these two things, entities and variations in quantity, are metaphysical because they are directly perceived without any need of numbers, counting, or measurement. They are perceived even by animals, so they can't be regarded as a function of our conceptual apparatus. And the parallel here is to concept formation. The similarities and differences that we perceive are metaphysically given. We don't create them. We, however, process them by our conceptual faculty. All right, now, in regard to math, what is it that is a product of consciousness here? Not given by reality. What we contribute is the fact of relating quantities to a unit. And that's what makes possible counting, numbering, measuring. Therefore, all these processes, counting, numbering, measuring, are epistemological. Numbers and measurement are the human form of dealing with quantity. They grow out of our cognitive need to establish relations among quantities. And that is our need because that's the means by which our particular type of consciousness learns. So without us, without our cognitive need, quantity would still exist. But there would be no unit selection, no relation to a unit, no measurement, no counting. So to sum up this point, when we measure, the factual content of our measurement is dictated by the entities we measure. In other words, by what we actually find when we study reality. Math, after all, is created as a tool of physics, not as a game for neurotic academics. So it must be based on and adhere to the nature of physical reality. But the point remains still true that the act of measuring and all the relationships it introduces are something which we bring to the scene. So like all objective phenomena, Numbers, and the whole of mathematics built on them, are a product both of consciousness and of existence, not of either alone without the other. Now think of this. Numbers, pristinely scientific as they are, the supreme tool of the physical scientist. Numbers, like concepts, are created by consciousness. The very thing which scientists today dismiss as mystical and vague because it is merely qualitative. Now, can you think of a bigger lie in the whole history of thought? How can the creator of numbers be regarded as having a lower status epistemologically than its own product and creation? If the faculty of vision makes it possible for you to see a chair, can you say, well, now that I see it, the chair is measurable and therefore scientific, but vision is a vague and purely qualitative process which belongs to an inferior world which the physicist should score? That is exactly what they're saying, though. Now I want to concretize for you the view that numbers are objective and not intrinsic or subjective. Are you tired? You have to look that way when you're young. Okay. Let us take as an example here one of the simplest constants in mathematics. The ratio of the circumference of a circle to its diameter. This was known since Greek times to be the quantity which we call pi. 3.14 forever. Now by saying pi as a constant, we mean that the ratio between the circumference and the diameter of any circle is always this exact number. Well, let me ask you, what does reality metaphysically contribute to this? Obviously, the fact identified by pi is a fixed fact of nature and is what it is independent of us. If we assign any other number to it, such as 3.3 or 6.8, we would simply be dead wrong. The fact of reality is what we must conform to. But now look at the other angle, the contribution of consciousness. Literally speaking, there is no ratio in nature at all. Because there's no such relating in nature. There are merely round objects. It requires man to abstract from such objects a circular shape in a single plane, and then to conceptualize different aspects of this shape as circumference and diameter, and then to bring these attributes together into the numerically measured relationship we call their ratio. You see, there's a huge difference there. Entities with all their qualities exist in nature apart from us, but numerical relations between abstracted attributes of them are a function of our form of consciousness. And that is the whole key to math's relation to reality. Pi, like any constant, is dictated both by reality and by consciousness, both by metaphysics and by epistemology. Like all numbers, it is objective. Now, by the way, Dave Harriman has a great theory of how exponents in physical equations, you know, the r squared or t cubed, the little 2 and 3, how they are objective as against intrinsic or subjective. And he just tossed it off to me one day. So if you're interested, ask in the question period. I had it in here, but it makes the lecture too long. But I'm happy to use the question period to give it to you. So where are we now? I've made 3 main points now. Numbers are inapplicable to their creator, consciousness, but are indispensable in physics because they are our form of knowing external reality by objective means. You got all that? Now we're moving in for the kill. Because we can ask our very opening question again now with some philosophic ammunition to answer it. This was our opening question, in effect. Isn't it a black mark against philosophy, a breach of its inductive and scientific character, that it doesn't use mathematics? Now, I regard that question as an intellectual aberration. Philosophy, as we've just seen, is the subject that explains what numbers are, and that thereby mandates their formation and use. Philosophy is what explains the relation of math to reality and to our cognitive faculty, and thereby showing the physicist that he must be mathematical and how he must use his mathematical tools, how he must rise from concrete measurements to experimental formulas to broader, mathematically formulated principles, the climax of which is all-embracing, super-integrating equations. How does the physicist know to do any of this? How does the physicist know to make use of numbers and how to make the proper use of numbers? How would he know it without philosophy? Now, in the first centuries after the Renaissance, the spirit and remnant of Aristotle worked as a guide to physicists, to keep them generally in a direction. But Aristotle and the other Greeks did not know about the role of math and physics. So modern scientists, in effect, merely stumbled into the need of math without understanding it, and they don't understand it to this day. And stumbling is not good enough and does not last. And thus you see the modern disintegration. So philosophy performs this indispensable feat in regard to math and physics. But now follow this. It performs this feat only because its task and its subject matter is the norms of consciousness. And as we've seen, consciousness isn't and can't be measurable. So this is the situation we're in. A subject, philosophy, that is inherently and necessarily non-numerable is the only one that can explain and validate the use of numbers in those sciences that study the physical world. How then can those same physical scientists turn around and say to philosophy, you're no good. You don't use the scientific method because you don't use numbers? I mean, I don't think Floyd Ferris, and why do you think could have come up with this? Physics is not the standard of philosophy. Mathematics is not the standard of philosophy. The reverse is true. Philosophy is the standard of physics and math. Philosophy tells these concrete disciplines what they are, how they relate to each other and to reality, and therefore what they must do to achieve knowledge of reality. In this process, now get this as a statement of the relation of philosophy to measurement. Philosophy itself does not do anything with measurements. It doesn't omit them. It doesn't take them. It doesn't relate them. It is beyond all such activities because, in one of my best formulations, philosophy is the arbiter of measurements. It is the arbiter that tells us when to take them and then omit them, as in concept formation. When to take them numerically and then retain and relate them, as in physics. And when not to try to take them at all, as in dealing with philosophy. Philosophy is the only validator of the physicist qua measurer. Now, who can have the effrontery in the face of this to criticize or downgrade philosophy for being merely qualitative and therefore non-inductive and unscientific? Philosophy, we showed last time, is perfectly inductive. But by its nature, it cannot use, and now get this, it cannot use and does not need numbers to achieve its inductions. It cannot use and does not need numbers to achieve its inductions. In physics, we've seen numbers achieve two specific related goals. We saw that several times in earlier classes. They enable the physicist to define laws, that is, to specify the causal relationship among objects, and they are the means of integrating laws into a unified total. But on both these counts, philosophy does not need numbers, and that's by its very nature. Physics needs numbers to relate objects through measurement of their attributes. But philosophy is not concerned with relating objects. It is concerned with remaining in contact with them, remaining focused on them. So for philosophy, if you will, there's only one object. That's the whole world. And the only relation philosophy seeks to define is the relation, the proper one, between that one object and the faculty of consciousness. So inductions in philosophy are indispensable, but preliminary. They're the necessary steps up the ladder to get us to the top, where in principle we can relate to and grasp reality, all of it. Continual induction in philosophy gets us to the point where all of our earlier philosophic gens merge into a single unity, which is packed with specific content, and yet, in effect, self-evident when you finally reach it. Because what does all of philosophy come down to? All of its branches, all of its content, all of its norms. You can phrase it in different ways. Think in order to survive. Or put it another way, perceive reality in order to stay in it. And that is really the whole message of a rational philosophy. All the other branches are forms of telling us. This is how you should conduct knowledge. Your consciousness is conceptual. Therefore, you have to do so and so and so and so to remain focused on reality. And this is how you must act if your action is to be based on the nature of reality, etc. But the whole thing, all of it put together is perceive reality. That is the sum of it. Now, you don't need numbers to discover this message. And you couldn't use numbers to express this message. What you do need is a mass of inductive concretization so it won't be a floating abstraction. Now, this brings me to a point that I don't know if I've talked about before in public, but it's a theory that I like, which I think is mine, but maybe not. Philosophy is really a circle. You end where you start. I hope that doesn't sound like Hegel. But I'm thinking of it in this way. When we're babies, at the start of our cognitive development, or children, we need, as we've said, some generalized guidance, some kind of norm to get our minds able to function. And it's something of the order of, the way to learn is to focus on facts. As without some such guidance, we just couldn't proceed cognitively. This guidance then makes possible the whole inductive step-by-step rise to the philosophic climax, at which point the new super-integrating norm is simply the full meaning of the implicit guidance that we started with, namely focus on reality. So in a real sense, I think we end where we started in philosophy. Although at the end we see and understand the specific norms in every area of life. We see the detailed norms that we must follow in order to obey the one overarching principle. Well, you see then, philosophy by its very nature is a unity. It's reducible to the above single statement, in relation to which everything else in the subject is a concretization or expression. Now, can you find greater example of integration in any subject than to say it's one statement? So if numbers are supposed to be essential to integration, obviously philosophy has no need of numbers to achieve integration. If your essence is unity, you don't need an additional technique of integration, whether mathematical or any other kind. So, I draw my conclusion. Is philosophy an inductive science or not? It does every single thing that inductive sciences do, and the things that they need numbers for, it does without numbers. Is it an inductive science? Well, if it didn't begin with observable first-level gens, if it didn't depend on properly defined concepts, giving it the green light to reach conclusions that go far beyond what is available on the perceptual level, if it made no use of difference and agreement in reaching its conclusions, if it made no attempt to explain man and his needs and actions through its gens, if it never rose to or integrated gens into principles and then into fundamentals, if all of this were not so, then you could say with plausibility philosophy is not an inductive subject. But given the actual facts about philosophy and its development and structure, such a claim is flat out false. And that's what I have to say about the borrowing of philosophy from the status of science, because it's not mathematical. And that's what I have to say about people who say philosophy doesn't live up to the rigor of the inductions of physics. Since philosophy is that which defines and validates the scientific method, and which therefore guides and validates the science of physics, no inductions made by physicists can ever be better off than the inductions which lead to the principles of philosophy, and especially of epistemology. So to wrap it all up, I'm actually getting near the end. The very least you can say, to be modest about it, to be humble about it, is that philosophy is just as scientific as physics, just as inductive, just as hard-headed and factual, just as objective, inescapable, and absolute. The proper methods and standards of thought, the virtues and values leading to human survival on a desert island or in society, the criteria of great art and literature, these are laws and facts as ruthlessly scientific as the laws of Newton or Maxwell. And I want to say that this is one of the most crucial truths all of us should know and spread if we are to save the world. Because to save the world, you have to know that the philosophy you are preaching is science. And then your listeners have to discover it too. The philosophies of the past, the ones that plunged the human race for centuries into the fatal morass of the problem of induction, are dead. In response to which I say, long live philosophy, the science of philosophy, the inductive science of philosophy. Thank you. Thank you very much. Thank you very much. Thank you very much. I didn't know whether that lecture would be interesting and clear or totally unintelligible, because one time when I read it, I have one opinion, and the next time I have the other. So I thank you very much for bending in a positive direction. When I write the book, I think it'll be a lot clearer and fuller. Now, I have written questions here, and I'm going to stay till 4:15, so that'll give us close to 35-minute question period, at which point I want to show you the gift that Dave gave me in connection with our course, a very special T-shirt which I'm wearing under this shirt, and which I'm going to take off the outer shirt, and you can come and inspect this T-shirt and wish that you had one like it. But I want to make a comment before the questions in regard to how I myself view this present course, because I do not regard it as the last word on induction, but as the first. And I'd like to explain this. So I'm going to be alternately humble and brazen in what I'm about to say. I have no doubt that at some point in the future, people are going to find flaws in what I have said this past week. Inaccuracies, omissions, confusions, new roads that I haven't seen. I know this from one simple fact. I have been stretched to the very limit of my knowledge in this course. I have nothing further within me to back up or elaborate on what I have said. Now, Ayn Rand always told me, don't lecture and don't write unless you know 5 times the amount of the material you're offering. And that is your context to, elaborate, answer questions, explain. I'm at the absolute end of my knowledge. You know everything now that I know. I can't squeeze one more thing out. Further, I'm sure that at some point in history, Ayn Rand's vision of a triple integration between math, epistemology, and neurology will be achieved. And that by the spiral method, this will bring a whole new context to the understanding of what I've been saying today. I'm certainly not omniscient, and I don't pretend by any stretch of fantasy to be in the league of a major philosopher. And I do not claim to be the father of any branch of reasoning. I think my legitimate claim lies in the fact that I have started this week a rational approach to this crucial form of cognition. Now, many good people have studied and wrestled with the subject in the past, and some have made valuable observations. But no one, to my knowledge, has worked at it within the context of Ayn Rand's theory of concept formation. None have done so within the framework of her fundamental view of the universe and of knowledge. And so all the earlier suggestions, even the better ones like those of Bacon and Mill, have petered out and left us with the perennial problem of induction. And that's what I mean by saying I've taken the first step. To my knowledge, I'm the first one, and through this course, to tackle the problem of induction head-on in all its key aspects from the perspective of objectivism. And that step, I think, is a requirement to get the whole area started. Now, I think if I go ahead with my new idea for a book, that'll be another step in the path. But I know that the path of future epistemology is great, long, and arduous, and that it'll have to be followed for many decades or centuries to come. But whatever my limitations in this course, I think I can take pride in the fact, this is where I become brazen, that I have left you something which will advance the cause and help you move further. So I want to conclude my formal part by thanking you for sitting through these long, difficult lectures and for being such a terrific, receptive audience. Thank you.
My question is, I'd like to hear David Harriman's explanation of the nature of exponents.
Do I have to repeat the question? Yes, no? No. Yes, okay. He wants to know Dave Harriman's explanation of exponents. Now, I just happen to have it right on the very top here, because I wrote it out and then cut it out. Now, I don't think that either Dave or I have a proof of this claim all the way through, but some great examples of it. And in any event, it's a provocative way of seeing in a different form the role of consciousness in creating numbers. The intrinsicists always marvel at the fact that God uses such simple numbers in equations. The law of circular acceleration where A equals V squared over R. Why such a simple thing instead of A equals V to the 1.49 over R to the 0.6? Now, there is an inherent simplicity in the use of exponents in physics, and I'm leaving aside what I don't know. But the simplicity is not because God thinks in integers, and not because we have arbitrarily found integers to be subjectively convenient. And here, Dave came up off the cuff with a brilliant idea, and I want to try to present it to you accurately, and he's right here. So if I misrepresent him, he's free to say so. He said to me, in effect, one day, not necessarily in these words, Exponents are introduced by our own mathematical operations. If we have a quantity in one equation, we establish that relation by focusing. If we have a quantity v, like velocity, in one equation, we establish that relation by focusing on v and reaching a relationship between it and something else, and thus an equation. And if you still have the handout here, you look to the first time we used v in circular acceleration, and we had the equation delta r over r equals delta v over v. That's the first time we introduced v to reach an equation. That was the first appearance of v. Let us say the result of our first operation. Now, then we work out the implications. And in working out the implications, we bring in v a second time. And if you look down to that same handout, at a certain point, it says multiply by v in order to reach the final result of the instantaneous acceleration. So there are two separate introductions of v, two separate operations with v that we perform in analyzing the situation. Well, said Dave, isn't that obviously connected to the fact that it shows up in our equation as v squared? In such a case, the little 2 indicates that in manipulating our equations, the product of our relating capacity and need, we go through 2 equations or 2 steps involving v. So the 2 really indicates our operations. And of course, he stressed that our operations aren't arbitrary, but like all conceptual thought, have reality at their base. Now, did I get that right? Yeah. Well, I thought that was stunning when he presented it, because it makes clear this reality is still the base, but it shows in such graphic form that we are summarizing our own operations in the number, that we create the exponent by the fact of having to solve equations a certain way. He could make a name in the philosophy of math simply by publishing that if there was anyone to listen to it. It's a brilliant, brilliant idea. Okay, next question.
Hi, you said it'd be fun if I came up and said, that's false. Unfortunately, I can't do that, but I'm going to try to start the question.
Yeah, you want to challenge the birthday cake analogy, right?
No, I like that one. The question was, doesn't what you're saying here with regard to the unique human capacity to identify a unit and measure on its base show that the people who are trying to say that animals conceptualize, in a sense, are barking up the wrong tree? And what I mean is, what I mean is, they aren't counting or using units or anything like that. At the most, some of these chimps are parroting and saying that they sort of understand what the words can be associated with, but there's none of that either implicit, what you're calling the pre-conceptual quantitative relation going
I think that's an excellent point.
And certainly not counting. And then my other question was, does the crow really have a crow? Do you see what I mean?
Well, the crow, yes. Well, let me take the first one. I agree with you completely, that animals who are said to have concepts because they have a vocabulary are not comparable to human beings, and precisely because they don't process the data. They learn by association with human beings who point to certain things. That's the way our dog, we figured out once, has about 27 words. But he certainly never, or she certainly never organized it and related them to a unit and found that they were all commensurable. Obviously not. So that's certainly true. The second one was, does the crow have a crow? In other words, can the crow count?
Right.
No, the crow really can't count. If you remember, I said the crow, or I should have said, Ayn Rand said, the crow can hold up to so many units in a frame of consciousness. We can say the crow holds 3 and no more. The crow can't say that. So it's not that the crow says, it's past my limit now, I can only go up to 3. We say, looking at him, what he thinks is out of the question, too much. That's all he can think in qualitative terms is 4. See the difference? That's a good question. I thought for me you were going to stump me. Yes?
Hello. You mentioned about consciousness and its definition. I think something of the faculty of perception of reality or a cognitive faculty, but in any case, a continuous phenomenon. But as I understand it, human consciousness is a discrete phenomenon. I mean, an attribute of a volitional being is you can either have it or not. An animal is only volitional or not. So my question is these two aspects of consciousness, the analog one and the digital one, it seems like they're two separable things being packaged together.
Well, they are two different things, but you are packaging them together, unfortunately.
But you're not.
No, I'm not. Let me try to explain to you. The fact that consciousness, I didn't say is continuous. I said consciousness, certain conscious processes, to be exact, are continuum. It has nothing whatever to do with the fact that either you have consciousness or you don't. The question is, when you have it, do you have something that has quantitative continuum or not? There's no contradiction, no conflict, and no paradox between saying this attribute is either there or not there. But when it's there, it exists on a continuum. Where's the problem in that?
Only in the definition of consciousness when it exists, as distinguished from an animal consciousness to a human one, whether or not it's...
Why is that a problem?
Because it seems as though that animals are able to do many of the perceptions of reality that you're talking about. That humans...
So you're not, in other words, let's suppose we agree with you that there is not a continuum between animals and humans, which I certainly agree that there isn't. Okay. That there's a discrete difference in kind. That is completely irrelevant to the question of whether the processes of either, whatever they can perform, exist on a continuum. Completely irrelevant. Suppose that all that animals can do is perceive. They can perceive more intensely or less intensely. I mean, so that it's a linguistic issue that you're raising. I'd like to go on to the next question.
Would you say that knowledge of numbers and counting is necessary for man's survival, even if he just has a primitive system like the Aborigines? And if so, wouldn't theory of number formation have to be a part of general epistemology?
Well, no and no. Men can survive, if you want to call it that, on all levels of cognition. And if you go back to the sufficiently primitive, quasi-perceptual level, because remember, concepts develop one step at a time. It's not as though, that's a continuum. It's not as though we start off on the perceptual level and the next day we wake up with Webster's dictionary. You have to form them one at a time. And you have to gradually acquire a conceptual vocabulary before you can even conceptualize numbers. So in the earliest forms of the species, they can survive without numbers just as they can survive without many concepts, because they are transitional between a perceptual level creature and a conceptual level one. At the point at which they become fully conceptual, then they have to have some kind of numbers if they're to advance beyond what we call the childhood stage in civilization today. Now, today a child can function on what we call a purely qualitative level up to a point, but not beyond that point. He can't get into science and higher complexities of knowledge of reality if he doesn't have numbers. So in that same way, a primitive society could survive without numbers so long as they remain close to the ostensive, to the given. As soon as they rise above a certain point, though, they either have numbers or they're nowhere. Now, what was your other question? I forgot.
If that was true, a theory of number formation...
No, and all that philosophy does, now remember, philosophy is not supposed to require specialized knowledge. It's supposed to be available to anyone at any time. Now, what has philosophy really got to say in regard to numbers? The theory of the objective versus the intrinsic and the subjective. That is a view of the relation of consciousness to existence that is accessible in principle to anyone. And all philosophers have had some view on that subject, and all people have some view on that subject, even though they wouldn't recognize the terminology. That is really all philosophy has to say. Now, if you then go into mathematics, into what's called the philosophy of mathematics, all of the philosopher then can do is apply that philosophic trichotomy to the status of math. He is not then forming a number system. He's not doing anything within math. He's from the outside looking at math and reality and saying there's three models of their relationship. These two are wrong. But the actual formation of the number system is no more a part of philosophy than the formation of the laws of physics is a part of philosophy. There's a philosophy of physics and there's physics. And the same way there's a philosophy of math and there's math. And the philosophy of math and the philosophy of physics depend on knowing philosophy, not on knowing math and physics. Although it doesn't hurt to know a few things, but that is not your subject. Yes, sir. I have some written ones here that I forgot. Did you all get this handout on the... Yeah. Okay, fine. Yes?
My question is about two conceptions of proof and how they relate to each other.
Okay.
One as the idea of a standard that you work toward, and when you fulfill it, then you have certainty.
Say that again?
The idea of a standard that you know you have to sort of figure out in advance and work toward.
Oh, I see. Okay, that's the one I mentioned in OPAR, yeah.
Right, as opposed to building up by integrating generalizations, and at each stage it's certain. So you don't have sort of an end point that you know in advance.
Yeah.
And so the question is, what's the relation between the two? Is one subsuming the other? Or?
Well, the broad issue is you have to know what proof is before you can say that something approaches proof or has achieved it. Now, I was talking there in the context of passing from possible to probable to certain. And I was saying you can't even get into the category of possible until you know where you're going. But if you get certainty right away, then you don't have to know anymore because you know what you're going for, you've hit it. So your proof is inherent in the experiment, say. You don't have a long, complex process of building, so it's the same process. It's just that sometimes you can go directly from the data to a conclusion, and sometimes you have to go through a long, tortuous road. And I'm saying, in both cases, you have to know what you take as proof. But in the one case, you know it in the act of coming to the conclusion, so there's no further problem. Does that answer?
Yes.
Okay. Next.
Can you say anything about Ayn Rand's interest in higher mathematics as relating to epistemology? I seem to recall she was studying that.
Can I say anything? Do I have to repeat these questions? Not really. I can't. I know that I don't want to ascribe this to her, but I think she thought at some time, at least as a possibility, as a hypothesis, that just as algebra's relation to arithmetic was illuminating of the nature of concept formation, even more complex or advanced branches of science, of math, such as calculus, differential equations, and so on, might be that to other elements in epistemology. In other words, she was convinced, this much I do know, that there are many connections between math and epistemology that she had not discovered. And she was working on, when she died, on learning higher math, specifically from the point of view of trying to get enough of a handle on higher math to see them. And she would certainly have seen them in an instant with her mind, but she didn't live long enough to get to the higher math. But she was convinced that this issue opened up a whole area and was not just an oddity of concept formation, and that it also tied into the nature of the brain. And that's why those were the three things she was interested in. Now, she was also really interested in the fact that the brain has its own yes or no type of system, like computers do, you know, the way, I don't know, nerves, whatever. and off and on type system. And she was sure that there was going to be a time, but she was not a rationalist, and she wanted to study those subjects. And I think it's a tragic loss. We'll never know. Someday someone will know, but I doubt that any of us in this room will ever know what she would have figured out if she lived another year. That's it. While we're on her, let me take just one written question which I got. Your comment that the great physicist immediately jumps to the generalization once he grasps the pattern brought to mind Ayn Rand's description of how she came to her theory of concept formation. In other words, that although she knew she had further items to check, she knew that she had it when she got it. Could you comment? Yes. I think that's a perfect example of exactly what the great scientist does, because she didn't do it out of the blue. She already had a whole context. Now, she didn't have worked out a whole theory of philosophy, but she had already long since dismissed the supernatural in any version, including, mystical insights into something common. And she had long since dismissed any form of subjectivism and had held that you must be guided by reality. And she had long held, and arguing with skeptics, that consciousness has identity, and that what's called naive realism, that we just perceive without our consciousness having any relevance, was wrong. She knew that consciousness and reality each make a contribution in cognition. She knew that in general terms. She knew and admired from Aristotle the idea that selective focus was essential to abstraction and the formation of concepts. And she insisted that she was strong on what she learned from Aristotle, that concepts are our way of grouping or relating or classifying percepts. Now, given all of this, you can almost see the discovery ripening in her mind. Oh, one other thing, she had great respect for mathematics. Always, even in We the Living, if you remember. And Kira wanted to be an engineer and thought math was the only subject where you didn't have to listen to lies. And she knew, of course, that math pertained essentially to establishing measurements. So she came with all of that, and then she had a conversation one day with, it was a Rose, I think was the example, wasn't it, with a Thomist, who said, where is the rosiness in a rose? And she said, well, let me see what my mind does. And she followed the process. She just said, there's one and there's another. In imagination, there's another. Now, one is bigger, one is smaller, one is brighter, one is duller, one is sharper, one is whichever. And it just all came together immediately in her mind. Well, obviously, I'm relating them by variations along a quantitative continuum and then just ignoring those variations. And that fit into something I'm doing, something reality is providing, the essential role of measurement, and ending up with a relationship. And at one glance, she knew that's it. Now, then she went ahead and checked it with all the different categories of concepts and so on. But this questioner, Bennett Karp, is absolutely right in saying this is a perfect example of great scientific thinking. They see one example and they know, whereas the professors and the researchers on government grants can see 1,000 examples and they don't have a clue. I'm sorry, I looked at you all the way through because it was a written question and I took it that it was yours. Okay, what's your question?
This is just a clarification, I think. You said something like that there are two forms of measurement, preconceptual and approximate.
No, preconceptual is approximate. Okay. And then conceptual is exact and numerical.
And the question was, it seemed to me that would imply that philosophy was approximate.
No.
I know you wouldn't say that.
Philosophy is, when I say measurement does not apply to philosophy. Neither kind applies to philosophy. Remember my statement, philosophy does not measure in any form. It's the arbiter of measurement. What I was trying to say is that when you form concepts, you use one type of measurement. It's implicit, it's non-numerical. Obviously, when we form the concept length, we have no numbers. We just see more or less. That's what I mean by approximate. One is bigger, one is smaller. But you can't say one is 6.8 times bigger than the other. If you had numbers at that stage, you'd already be on an advanced conceptual level. We're talking about the formation of concepts. It's in that sense that concept formation, the formation of concepts, takes place by grasping quantitative relations in an approximate, non-numerical form. That's what I call pre-conceptual measurement, because it's done by perceptual awareness of variations in quantity.
Okay, that makes sense.
And then when you have a conceptual vocabulary and conceptualize numbers, you can now establish the exact relation to a unit in terms of numbers. That's the difference. Okay. But philosophy doesn't use either kind. Yes.
What is the relationship between an equation which happens to fit the data and a causal explanation?
Say that again? Okay. Oh, I thought there was going to be... Okay. You ended the sentence faster.
Okay. Yeah. If you do experiments and you take the data and it fits an equation, what's the difference between doing that and coming up with a causal explanation?
I'm not sure I know enough to answer that, but in my humble experience of physics, there are a lot of things that are called equations, which are not causal relations. There's simply a relation between two sets of numbers that have been pulled out from somewhere, perhaps on an empirical basis, perhaps not. So I wouldn't go so far as to say every equation equals causality. What I say is all scientific discovery of causality is in the form of equations, not necessarily the reverse. Do you agree with that, Dave? Yeah. Okay.
You talked about how axioms and first-level generalizations are starting points.
Yeah.
And when I first learned about axioms and their self-refuting nature, I was very impressed, polemically and so forth. Is there a similar thing for first-level generalization?
In which subject, philosophy or physics?
Physics.
No.
Okay.
There is no such thing as a first-level generalization in physics which you can show, or without which you can show the person is stultifying himself, that he reaffirms it in its denial, as you can with philosophic axioms. And that is because the physicist studies concretes. And someone may never stumble across the concrete that he started with. No one concrete is indispensable. There are many different ways to start. What you can say is that the principle involved, namely starting with perceptual, self-evident data, that is something that you can't challenge without refuting yourself. Because that's the axiom of sense perception. But not any concrete sense perception. That's where philosophy has it over physics, because philosophy is the basic norm that you have to use to get going. And therefore, if you don't use it, you can't go. Physics is not that. And therefore, it just has to rely on the simple fact that something is self-evident, with no additional club to beat the skeptic over the head with. Now we have about 3 or 4 minutes by my watch, so maybe we'll take these 3 questions and that's it. Yes?
I wrote this down during your lecture. I think you said, I want to make sure that I got it right. We grasp the quality of things only by grasping their quantity. Did I write that down correctly? And if so,
you did, but I'd hate to see that on a T-shirt. Yeah, but I agree with it, given everything else that I said. Yes. And your problem with that is?
I don't have a problem with it. I introspected and began to agree with it. I was just wondering if you could elaborate on it.
Oh, I just gave a 2-hour elaboration. I couldn't give any more.
I heard once that one of Ayn Rand's achievements was to see that logic pertains not only to the process of deduction, but to the entire process of reasoning, every form of human reasoning. Can you talk about how logic pertains to induction? Or not yet?
Well, I don't even know what you mean by logic, the art of non-contradictory identification. Well, induction is a form of that. If you observe certain facts, and you observe that this is the only difference, and you observe the facts of causality, and you put them all together non-contradictorily, you come to a certain conclusion. But that does not turn induction into deduction. There is still a difference between applying a generalization and reaching it. But in both cases, you're coming to a conclusion based on various kinds of data and premises, and your conclusion is non-contradictory. So you're using logic. The trick is you don't think that it has to be deductive in order to be logical. It merely has to put together data in a non-contradictory way in order to qualify as logic. Keeping in mind the other two things that I mentioned in OPAR, hierarchy and context. Keeping the full context and the hierarchy of knowledge. If you identify in a non-contradictory fashion, that means you bring everything relevant to bear. The full integration, then that's logic.
Yeah, I'm sorry, I didn't mean to ask, is induction logical? I guess I meant in the field of logic, we have many rules to tell us how to deduce.
I gave you 5 rules in induction. That's the best I can do right now. And I don't have them named according to various, like Barbara and Philopterant and Dario, the way they did in the medieval period, maybe in 10,000 years. All right, sir, the last question.
Okay. Given what you've studied in showing that philosophy and its inductions are not necessarily quantitative in the attempt to make them or disqualify
not
philosophy.
Necessarily, are necessarily not.
Right, and that the argument against philosophy that it's not scientific is based on a false view of philosophy's inductions. Have you given any thought to other non-quantitative fields, say in the humanities?
That's a great question. I wondered if anybody would ask me.
I mean, for example, history?
Yeah, it's a very good question.
And how its inductions are different, but not.
All right, I'm going to leave you, since it's 1 minute only and I have to catch a plane and I want you to see my T-shirt. I'm going to leave you a provocative answer. All subjects which deal with man, which other than anatomy and physiology, in other words, that deal with man qua conscious actor, come under the same rule as philosophy. And measurement and numbers and math is inapplicable. So it's inapplicable to history, it's inapplicable to psychology, the whole thing for the same reason that it's inapplicable to consciousness. The apparent exception is economics, which is filled with numbers and deals with man as a conscious being. And I have a section on that, which you unfortunately are not going to get to hear. But if you want just a clue to it, in my opinion, economics is just like philosophy. That is, numbers are not literally applicable. And all the numbers in economics, such as, for instance, prices, which look to be very exact and numerical, are really what Ayn Rand calls teleological measurement. In other words, a price, when you say it's $3.9, that is not an absolute number. You're saying, this is what I prefer relative to this. This is what I would buy rather than this for this amount. So it's a grading of preference. That's what she called teleological measurement. That has nothing to do with the numerical measurement that we talk about in the physical sciences. So in that sense, I draw a line right down the middle. The only one that I would say I'm not sure about is biology, because I don't know what life is.
So the distinction between humanities and social sciences and sciences, that's really an arbitrary distinction, trying to quantify the human side.
Well, yeah, I'd go even further and say that social sciences is an arbitrary, but let's leave it at that. Okay. Thank you very much.